Hello guys, so today we'll start with another topic, that is dental investment. So you can expect at least one question from this topic. So these are the contents which we are going to discuss one by one. So coming on to the dental casting investment, a material consisting principally of an allotrope of the silica and the bonding agent. The bonding substance may be gypsum for use in the lower casting temperature, or phosphate or silicates for use in the higher casting temperature. So basically gypsum is used for the lower casting temperatures and the phosphate and silicates are used for the higher casting temperatures. So casting procedures involve a wax pattern of the object to reproduce, a suitable mold material that is known as investment, which is placed around the pattern and permitted to harden. Can you see this? It's a suitable mold material which is known as investment, which is placed around the pattern and permitted to harden. So suitable furnaces for burning out the wax patterns and the heating the investment mold, and proper facilitates to melt and cast the alloy. What all are the requirements for an ideal investment? So it should be easily manipulated. So the mass is mixed and manipulated readily. Paint the wax pattern easily. Hardens within a relative short time. So it is having a sufficient strength at the room temperature, which permit ease in handling. Have the strength at a high temperature, which to withstand the impact force of the molten metal. The inner surface of the mold should not break down at a higher temperature. It should be stable, or you can say it has stability at the higher temperature, which do not decompose to give off the gases that could damage the surface of the alloy. It should have sufficient expansion to compensate for the shrinkage of the wax pattern and the metal. It should be beneficial casting temperature. So it should have the beneficial casting temperature. The thermal expansion versus the temperature curve should have a plateau of the thermal expansion over the range of the casting temperatures. Next is the porosity. Porous enough to permit the air or the other gases in the mold cavity to escape easily. Should have a smooth surface with the fine details and the margins on the casting. Should have an easy of divesting. The investment should break away readily from the surface of the metal and should not have reacted chemically with it. Should inexpensive. Coming on to the basic constituents of an investment, that contains a binder material, a refractory material and other chemicals. Started with the binder material. Refractory materials alone do not form the coherent solid mass, therefore binder is needed. The common binding material used for casting gold alloy is alpha calcium sulfate hemihydrate. Important. For high temperature casting, investment are phosphate and ethyl silicate, as I have already told you in the definition that for the higher temperature casting the investments are phosphate and ethyl silicate. For the lower temperature casting the investment are gypsum. So this material is usually a form of, your refractory material is usually a form of silicon dioxide, such as quartz, your tridymite and your cristobalite. This is your tridymite, your cristobalite and your quartz crystal. So other chemicals are sodium chloride, boric acid, potassium sulfate, graphite, copper powder or magnesium oxide, which are added in a small quantity to modify various physical properties. For example, small amount of chlorides or boric acid enhance the thermal expansion of the investment bonded by the calcium sulfate. Now coming on to the type of casting investment. Gypsum bonded investment, it is very important. Phosphate bonded investment and ethyl silicate bonded investment. Out of these three, gypsum bonded investment is slightly important because you can get, if you get a question, you can definitely get from the gypsum bonded investment. So coming on to the gypsum bonded investment, according to American Dental Association or American National Institute for Standard Specification number 2, for casting investment used for gold alloys. So basically there are two types, that is type 1 used for the casting inlays and onlays crown, type 2 for casting complete and the partial denture base. So before starting with the gypsum bonded investment as a mixture, I would like to tell you some important point. Please note it down. That alpha hemihydrate, it acts as a binder in gypsum bonded investment material. As you all know that it is used for the gold alloys. So when heated above 700 degrees Celsius, decomposition occurs and silicon oxide is emitted, which contaminates the casting. Very important line, please note it down. It is of two types, as I've already told you. Next is the normal setting expansion is 0.5%. I repeat, the normal setting expansion of the gypsum bonded investment is 0.5%. Hygroscopic expansion of the gypsum investment material is 1.2 to 2%. And thermal expansion is 1 to 2%. It's very important points. Just keep this in mind and remember. Now coming on to the gypsum bonded investment is a mixture of four types of material, that is the binder, the refractory material, a reducing agent and a modified chemicals. Starting with the binders, 25 to 35% of alpha calcium sulfate hemihydrate are used to react with the water and on hydration binds the silica together to impart sufficient strength to the mold and to contribute to the mold expansion by its setting expansion. Refractory materials contain 65 to 75% of quartz or cristobalite or a blend of these two, the quartz and the cristobalite. It withstands with the higher temperatures, provide mold expansion by thermal expansion. It has a reducing agent such as the powder charcoal, which reduced any oxide formed onto the metal. If present, should not be heated more than 650 degrees of Celsius. It is very important value. Fourth one is the modifying chemicals, contains 2 to 3%. Example is boric acid, sodium chloride, which inhibit the shrinkage on heating. Coming on to the gypsum, it acts as a binder, as I've already told you that alpha hemihydrate, in this the alpha hemihydrate is a binder. So it acts as a binder for the investment used in the casting gold below 1000 degrees Celsius or 1800 degrees Fahrenheit. When it is heated to temperatures required for complete dehydration and sufficiently higher to ensure the complete casting. Therefore, it shrinks and sometimes may fracture. SiO2, silica oxide. It is the refractory material. It regulates thermal expansion. Gypsum contracts during heating and silica eliminates this contraction and change it to an expansion. Silica exists in at least 4 allotropic forms, that is quartz, tridymite, your cristobalate and fused quartz. So when the quartz or tridymite and your cristobalates are heated, a change in the crystalline form occurs, that is called inversion at a transition temperature, characteristics of the particular form of silica. Very important point. So basically what happens is your beta quartz get heated at 870 degrees Celsius. It leads to the formation of beta tridymite, which further heated at 1475 degrees Celsius, which leads to the formation of beta cristobalate, and further when it heats about 1700 degrees Celsius, it is formed into fused silica. So the density decreases and the volume increases as alpha goes to beta form, and a rapid increase in the linear expansion occurs. So only quartz and cristobalate or their combination are used as investments. Depending upon the type of silica, principally used investment are classified as quartz investment or cristobalite investment. These names may come. So fused quartz exhibits no inversion at temperature below its fusion point due to its very low coefficient of thermal expansion. It is of little use in the dental investments. In the powder form, inversion occurs over a range of temperature rather than instantaneously. Coming on to the properties, setting time of the gypsum bonded investment. According to AD specification number 2, minimum setting time is of 5 minutes and a maximum of 25 minutes. The mortar investment usually have an initial setting time between 9 to 18 minutes. Effect of the temperature on the gypsum bonded investment. So investment expand as it heated from the room temperature to about 105 degrees Celsius. Contract slightly or remains unchanged up to 200 degrees Celsius. Depending on the silica composition of the investment, varying degree of expansion occurs between 200 to 700 degrees Celsius. So these are thermal expansion curves for the calcium sulfate bonded investment. A is the hygroscopic expansion and B is the thermal expansion. So types of expansion that occur in the gypsum bonded investments are setting expansion, hygroscopic expansion and thermal expansion. Normal setting expansion gypsum bonded investment. According to AD specification number 2, 0.6% mortar investment is about 0.4%. A mixture of silica and gypsum investment results in a greater setting expansion than a gypsum product used alone. Very important line. The silica particle interfere with the intermeshing and interlocking of the crystals as they form, resulting in the outward thrust leading to expansion. So setting expansion of the mold compensates partially for the casting shrinkage of gold. The normal setting expansion as determined in the laboratory is different from the effective setting expansion that occurring in the practical usage. Coming on to the hygroscopic setting expansion, this occurs when the gypsum is allowed to set under or in the contact with water. According to AD specification number 2, for type 2 investment, minimal hygroscopic expansion of 1.2 and maximum of 2.2, as I've already told you, maybe 6 times more than the normal setting expansion. In one method known as the water immersion technique, the investment mold is placed into water. Another method is water adit technique. Here the measured volume of the water is placed on the upper surface of the investment material within the casting ring. This produces a controlled expansion. See, this slide is very important, and these points are also very important. Coming on to the limitations of the gypsum bonded investment. Above 1200 degrees Celsius, a reaction occurs between the calcium sulfate and silica, that is CaSO4 plus SiO2 leads to CaSiO3 and SO3, which leads to sulfur trioxide. Okay, from sulfur dioxide to sulfur trioxide. So the sulfur trioxide get evolved, causes the porosity in the casting, contributes to the corrosion of the casting. For this reason, gypsum bonded investments are not used for higher fusing alloys like cobalt, chromium. In such cases, phosphate or silicate bonded material are chosen. So before coming on to the phosphate bonded gypsum material, I have some important MCQs regarding the gypsum bonded investment material. Number 1 MCQ: carbon is added to investment powder to facilitate the answer is divesting. I repeat, carbon is added to investment powder to facilitate the investment. Second MCQ is: chief disadvantage of type 4 gypsum dye is susceptible to abrasion. I repeat, chief disadvantage of type 4 gypsum dye is it is susceptible to abrasion. Next, quartz is added to gypsum bonded investment to counterbalance contraction of gypsum during heating. Next MCQ: a thinner mix in gypsum bonded investment will result in, your answer is will decrease in setting expansion. It was asked in your AIMS exam. So pickling removes the surface oxides from the gold casting. It was asked in your PGI as well as AIMS. I repeat, pickling removes the surface oxides from gold casting. Next MCQ: strength of gypsum investment is dependent on, the answer is gypsum. Next, gypsum bonded investment should not be heated over, your answer is 700 degrees Celsius. So basically binder, next MCQ is binder used in gypsum investment is, your answer is calcium sulfate monohydrate. So I hope it is clear to you all. Now coming on to the phosphate bonded investment. The popularity of the metal ceramic restorations which use higher melting gold alloys and trend towards the use of inexpensive alloys have resulted in the greater use of phosphate bonded investment. So according to ANSI and AD specification number 92 and by ISO in 9694, type 1 for used for the inlays, grounds and other fixed restoration, type 2 for the partial denture and other cast removable restorations. So before moving to another slide, I have some important point regarding the phosphate bonded investment. Please note it down that magnesium oxide and the monoammonium phosphate is act as binder. I repeat, magnesium oxide and monoammonium phosphate act as a binder in phosphate bonded investment. Next point is colloidal silica suspensions are used in place of water, which helps in greater expansion of the investment. So in place of water we use the colloidal silica expansion, which help in greater expansion of the investment. Next point is phosphate investment with the carbon is used if casting alloy is gold. Very important point, I repeat, phosphate investment with carbon is used if casting alloy is used. Next important point is phosphate investment without carbon is used for carbon sensitive alloys such as the base metal and the silver palladium alloys. See, phosphate in this, when the carbon is used, it is used when you are using the casting gold alloy, but without carbon, if you are using the phosphate investment material, so it is used for the carbon sensitive alloys, that are the base metal alloys and the silver and the palladium alloys. Very important points. Coming on to the composition, as I've already told you, it consists of a filler, that is refractory, a binder. So silica in the form of cristobalate or quartz or a mixture of these two, and forms approximately 80% maximum percentage. It provides a refractoriness and a high thermal expansion. Binder, it is the magnesium oxide, as I've already told you that magnesium oxide and monoammonium phosphate is act as a binder and a phosphate. So originally phosphoric acid was used, but at present monoammonium phosphate is used, and it can be incorporated in the powdered investment. The powder is mixed with an aqueous colloidal silica. In this we are using aqueous colloidal silica instead of water suspension and invested. As alloy used in the metal ceramic restoration have higher melting points, their contraction during solidification is greater, and the aqueous colloidal silica suspension compensates for this. So the setting reaction is, the chemical reaction takes place is, it is NH4H2PO4. When it reacts with the magnesium oxide in water, it forms your magnesium ammonium phosphate, which is a polymeric. The magnesium oxide never fully reacts, thus a predominantly colloidal multimolecular magnesium ammonium phosphate is formed, coagulating around excess magnesium oxide and fillers. So this reaction is very important, please keep this in mind, and this product. So setting in the thermal expansion, during the setting reaction a slight expansion occurs, and this is more in the colloidal silica mixed materials than for the water mixed material. That's why we are using the aqueous colloidal silica. So thermal expansion is also greater for colloidal silica mixed material. The combined setting and the thermal expansion for phosphate investment is around 2%. Please keep this in mind if the special silica liquid is used. So your thermal expansion will be around 2%. Similar to GBI and PBI, that is your gypsum bonded investment and phosphate bonded investment mixed with the water show a shrinkage of about from 200 degrees Celsius to 400 degrees Celsius. This contraction is almost absent in the colloidal silica mixed material. Both the setting expansion and the thermal expansion increase as the concentration of the special liquid increases, because in the phosphate we are using the aqueous colloidal solution rather than water. A decrease in the expansion can be achieved by increasing the liquid powder ratio rather than by decreasing the concentration of the liquid. Coming on to the working and the setting time, warmer the mix, faster is the set. The reaction gives off heat which further accelerates the setting. Increased mixing time and mixing efficiency results in a faster set. These two factors give the smoothness and accuracy to the casting. Mechanical mixing under vacuum is preferred. An increase in the liquid powder ratio increases the working time. Other properties: the cohesive strength is high. They do not have to be contained in the metal casting ring. The material is allowed to set inside a plastic ring. We are using a plastic ring in this as compared to metal casting ring, which is removed before heating. The porosity of the material is sufficient enough to prevent the build-up of back pressure. You will get a question if you have a question from this particular topic, maybe on the back pressure. It can be used for hygroscopic setting expansion like for gypsum bonded material, but rarely used in practice. So before coming on to the ethyl silicate bonded investment, I have some important MCQs which was asked in your previous examination. So your first MCQ was: phosphate bonded investment are not used for gold alloys. I repeat, phosphate bonded investment are not used for gold alloys. Binder and phosphate bonded investment, as I've already told you, it is magnesium oxide and monoammonium phosphate. Next MCQ is: investment material used for cobalt chromium alloys is phosphate bonded investment. I hope this is clear to you. So coming on to the ethyl silicate bonded investment, according to ISO 11246 June 13, 1996, it is used since 1930s for casting removable RPD of the cobalt chromium. It may be used for nickel based alloys. So it is used for casting base metal alloys at the high temperature, as we already discussed. And ethyl silicate based bonded investment binds by the formation of a gel derived from the hydrolysis of tetraethyl orthosilicate. So the binder the binder is very important in the gypsum. Okay, in the gypsum you have the alpha hemihydrate as a binder. In the phosphate bonded you have the magnesium oxide and the monoammonium phosphate is a bonder. And in the ethyl silicate bonded investment you have the silica gel as a binder. So before coming on to this, I have some important points regarding your silica bonded investment material. So as I've told you that the silica is the binder which may be derived from the ethyl silicate or the silica gel. It is used for the high fusing base metal partial denture alloys, as I've already told you. In addition to setting shrinkage, green shrinkage, very important point, very important word, green shrinkage occurred due to the loss of alcohol and water from the gel. I repeat, in addition to setting shrinkage, green shrinkage occurred due to the loss of alcohol and water from the gel. Next is the investment can be heated up to 1200 degrees Celsius. I hope these points are clear. So the formation of the polysilicic acid and the constituent three-stage. First stage of the setting reaction called the hydrolysis. In this, a colloidal silicic acid is first formed by the hydrolyzing ethyl silicate in the presence of hydrochloric acid, ethyl alcohol and water as follows. You have to keep this reaction in mind. So because a polymerized form of the ethyl silicate is actually used, a colloidal solution of polysilicic acid is formed instead of the simple silicic acid. shown in the above reaction. You can say this. So stage 1 is known as hydrolysis, stage 3 is known as gelation, that is solution is mixed with the quartz or cristobalite to which is added a small amount of finely powdered magnesium oxide to render the mixture alkaline. A coherent gel of polysilicic acid then forms, accompanied by a slight setting shrinkage. So basically this is the reaction in which the solution plus quartz of cristobalite and the magnesium, that is and ammonium chloride, which mixed and formed the polysilicic acid. Stage 3 is drying. The soft gel is dried to a temperature below 168 degrees Celsius. During drying, the gel loses alcohol and water to form a hard concentrated gel of silica particles that are tightly packed together. A considerable volumetric contraction accompanies the drying, which reduces the size of the mold. Now this contraction is called as green shrinkage. This is what green shrinkage is, and it occurs in addition to the setting shrinkage. So soft gel, when it is to a temperature of 168 degrees Celsius, it leads to the contraction and hard gel of the silica plus water. So silica bonded investment being more refractory than phosphate bonded investment and can tolerate higher burnout or mold casting temperature between 1090 and 1090 degrees Celsius, 1090 to 1190 degrees Celsius, or you can say up to 1200 are employed when the higher fusing chromium containing alloys are casted. Coming on to the porosity, the particles of the set material are packed so closely together that the porosity is negligible. So the air spaces or the vents must be left in the investment to permit escape of the gases. Investment of casting titanium. Titanium does not meet the minimal acceptable values for yield limit when used for the removable partial dentures. Therefore, titanium alloys such as Ti6Al and Ti6Al7NB with yield limits over the minimal acceptable values are used. So titanium has a high melting point and an inherent reactivity with the elements of atmospheric air, that is oxygen and nitrogen, and the components of the several investment material, especially at the higher temperature of 1727 degrees Celsius. So the reaction between the molten metal and some of the element of the phosphate bonded and other silica based investment material, that is oxygen, phosphorus and silicon, which results in the development of the surface contamination zone refers to as alpha case, which is consisting of a compound of a titanium primarily with silicon, phosphorus and oxygen. This alpha case zone is porous and brittle and is considered unfavorable because it reduces the ductility, fatigue and corrosion resistance. This zone may have a surface depth up to 1200 micrometer and result in the low bond strength between the cast titanium and dental porcelain. So to minimize the extent of the alpha case, new investment material consisting of oxides with a higher chemical affinity to oxygen than titanium, such as your magnesium oxide, your aluminium oxide, were introduced, though a thin contamination zone of approximately 0.20 to 0.40 mm is formed. So application of various types of investment materials. Dental plaster or stone, mold for acrylic dentures, gypsum bonded material, mold for gold casting alloys, very important, phosphate bonded material, mold for base metal alloys, gold casting alloys, mold for cast ceramics and glasses, mold for soldering, silica bonded material, mold for base metal casting alloys. Divestment, it is a dye-stone investment combination in which a dye material and an investing medium have an comparable composition. Divestment is a commercial gypsum bonded material. It is mixed with the colloidal silica liquid. The dye is made from this mix and the wax pattern constructed on this. Then the entire assembly dye and the pattern is invested in the divestment, thereby eliminating the possibility of distortion of the pattern upon removal from the dye. And during the setting of the investment, the setting expansion of the material is 0.9% and thermal expansion is 0.6% when heated to 677 degrees Celsius. So this is all about your dental investment. So you can expect at least one question from this, and in this the gypsum bonded investment is slightly important. So I hope it is clear to you. Just go through it once. I have told you the MCQs, important MCQs regarding the gypsum bonded, and important points also. Important points regarding your silica bonded, gypsum bonded and phosphate bonded, and your MCQs also. So this is all about the dental investment. Thank you.